Okay, so hi everyone, Senan this side, and in this video we are going to solve one of my favorite problems on LeetCode. And why? Because this game that you see, Snakes and Ladders, is something that I used to play during my childhood. So first we'll discuss the question, then I'll give you the idea that I'll be implementing, and I'll give you some tasks that how you would be able to solve this on your own as well if you want to. So what you are given is an n cross n integer matrix, and the numbers are labeled from 1 to n square in the Bostrophian style, which is like a snake. So like this, you go zigzag from bottom to top, starting from the bottom left. So this is what you are given, is something that you should not basically memorize this name, but you should just understand what this actually does. So you basically start a square one and you move to a new square. And how do you determine what is the next square? You determine the next square by calculating the next six values that you can actually jump to using a die. Basically we play it using a die, right? So, or dice, whatever you call it. So there are six values which you can actually take, and you have this minimum of this because you should not go beyond what is in the board, right? So if it goes beyond the values that is actually present in the board, you just terminate your uh, may, let's say for this case the iteration, you stop at that point. We'll see this in the code as well, and we will be more clear of how to do this. So six-sided die roll. So at max, at any position you have six possible destinations to go to. If the position that you reach has a snake or a ladder, you must move to the destination of that snake or ladder. So if you have a ladder, you go to a place that has a higher value than the position that you are currently at, and if you have a snake, you go to a position that is lesser than what you are currently at. Now the game ends when you reach the square, right? The final node, like the n is 6, you need to reach this position, and then and only then you will win. Now a board square is RNC, has a snake and ladder. So how do you detect if the board has a snake or a ladder? So the values, let's say this 35 would have okay, so this 14 would have a value. The grid itself, the board itself would have a value 35 placed in this location, so that if you see the value 35, you jump directly to that location, and if you are, let's say, at 17, you directly jump back to 13. Okay, so the point is the first and the final square do not have a snake or a ladder because you don't have. So the point is, if you have a ladder on the start position, you are basically having a dynamic starting point based on the location of the final point of that ladder. Anyways, if you, because you have to reach position 36, and if you see a snake, you have to come down. So that is not something you have to take in consideration as well. Okay, the next thing is okay, so return the least number of moves required to reach the square n square, and if it is not possible, return -1. Let's say all these are having the value. Let's say every element in this is having a value of let's say 2, and there are no ladders, and basically you have many snakes. So in that case, you would never reach any endpoint, right? So whenever you try to go across, a snake would bite you and you'll end up back at. So there is a possibility that the game is somehow not completable, or it cannot result in a win or a loss. Basically a win, you can lose anyways. You will lose obviously in that case if the board is full of snakes. Now you are, this, the constraints are, you are given a, let's say, a grid, right, of n cross n. The value of n is within this range, it's not too big, right? So at max you can have 400 elements in your grid. Now board I and j is either -1 or in the range 1 of this. So if you encounter a value between this, that means you are at the position of a snake or a ladder, and you have to jump to that location. Otherwise, if there are no snakes and ladders, you just have -1 position. Now squares are labeled as 1 to n square, do not have any ladders, or so that is fine. One more thing I wanted to point out is that you can only take a snake or a ladder at most once per move. So let's say, for example, you have a loop, right? From this you go to this 14 to 35, but let's say you have a snake at 35 as well, that would take back you to 14. So you would end up in an infinite loop in a way. So you do not want that, right? So, or let's say you have multiple steps and you can end up in a loop, you don't want that. So at max, if you travel through the snake or the ladder, you can do it at most one time. You do not have to do it repeated number of times. Now let's look at the implementation, and before that, let's discuss what do we actually require in this problem, right? So we have to understand what we have to do. So first of all is, since I need to return the minimum where it is least number of moves, what I need to do is to have a tree, a search tree, to find when the game would terminate. So what I think is we can use something known as breadth first search, right? So if you go around along the breadth, and whenever you encounter a value of, let's say, n square, that means you are at the last position and you won. So if you look at the breadth first search or a search tree in a game, so I'll highly suggest you to search about a game search tree, a game tree. In that you will see that if you do a breadth first search along the states of the game, and if you find a solution, so that would be the minimum possible solution. So that is the reason I'm using the breadth first search. Even if you don't understand this, you would have a pretty good idea of a graph search. Okay, so next thing is, somehow we need to have a relation between this 15 and the location in the grid, that is 3 comma 2. I need to have a relation between 15 and 3 comma 2. I need a way to convert this 15 to 3 comma 2 or 3 comma 2 to 15, one or the other way, right? This is a broad approach. I'm not saying that you require both of. I'm just saying that seeing the question, you need to have some idea of how you would traverse this. If you try to traverse the grid from, let's say, using two indices, row comma column. First, let's say you get 6, so you increment the value of column by 6. But if you reach the end, you increment the row and then you change the direction. And if you try to do that way, the traversing of the nodes in this matrix, it would be very difficult, right? You have to keep track of a lot of things. So what I would suggest you to is find a conversion between the indices of, or the location of this value in the grid with, okay, so basically the location of the this location of in the grid with the value in this position. You need to find a relation through that, and that is what I would be doing. So I just created a helper function to return if a number is odd or not, right? So that is something that I don't want to write many if and else statements. I want it to be as readable as possible. So the next is, I'll take the size of the board, let's say the n number of rows or number of columns as an argument, and I'll take a value. So this value would be either of any number between 1 to 31, right? Sorry, 1 to 36, 1 to n square. This takes a value, and it would return you a pair of integers, that is row comma column. And this is the logic that I'm going to use. So the row is basically using this logic and the column is this, and if either of this condition holds, you have to update the column like this and you return row and column. Now I know I went through this very fast, but what I want you to do now is to not see this code. I don't want you to see this code. The whole problem of this, so the main idea that the maker of this question was trying to do is to convert this Bostro style to a location on the grid. So that is the whole idea. So this is the main thing that you need to figure out to solve this question. So if you do this, you'll get the row and column, and I would highly suggest you to not look at the solution that I have. Try to do it with pen and with paper. Make 3-4 variations of this grid for different values of n and try to figure out the row and column. And I would highly suggest you to do that, because if you do this, this question is a piece of cake. Obviously you need to know the breadth first search, but otherwise this is something that would actually enhance your programming skills. This would push you to think algorithmically, and that is why I want you to do this. So convert to RC, that means convert to row and column. So given a value, convert to row and column. That is what this function is doing. Another function is this one, which we are not going to use in this problem, but just for the sake of simplicity, I have just written, so given a grid location, let's say 1 comma 1 this, so if you pass this through this function, you will get the value 26. Similarly, if you give 1 comma, let's say 4 in this function, give n, give 1 comma 4, this would return you the value of 29. So this is also something I would like you to figure it out on yourself, because that would make your job very simple, and it would make you understand that how do you actually do this. Now for these two conversions, I'll just give you a hint, right? So how do you approach? So whenever you have a numbers like this, right, 1 2 3, your grid is labeled with some numbers, sequential manner or a consecutive manner, what you have to do is to figure out the row, you need to do something divide by n. So dividing by the edge length or the number of rows or the number of columns in the grid would help you to determine the number of rows. Similarly, when you need to find the number of columns, you have to do this modulus operation. So since this is 1 to 30, 36, so but our arrays are zero based index, so basically I subtracted 1 from both of them, and then after I did a division operation and a modulus operation, get the row and value. It's not exactly like this. You have to figure out why this condition is like this. This is basically because when you go to this position, the direction reverses of the elements, and whenever you are changing the row, you change the direction of traversing as well, right? You travel in a zigzag manner. So that is what this if statement is trying to encapsulate inside it, the logic. So that's the idea. So whenever you have to find the rows, you need to divide it by the length of the or the number of rows or columns, and whenever you have to find the column, you have to do a modulus operation with the row or column depending on the question. Similarly, when you are trying to convert it to a value, what you have to do is multiply it, because we divided it, right? So we have to multiply it to get the location. Let's say to get back from a row and column to the number, you have to multiply it by n, and for uh, the reverse of a modulus operation, we would be actually is just adding the number itself. So that is what you have to figure out. So I'll just close this functions, and I would want you to do it, write this function from scratch without thinking anything. So this logic is independent of the programming language that you use. And now let's actually now look at the breadth first search that we are actually going to do. Now I get the n, I get the final value, that is n square, because I need this value of n square multiple times in the future. So what I would do is basically store that value, right? So that is the point of variables, right? Whenever you have to do a repeated operation on something, you store that value, basically one use of a variable. Now since we are doing a breadth first search, I am keeping a visited array with size final val plus one, because it's the numbers are one based, right? But it's not zero based, so that is why I'm adding 1 plus 1, so that I do not have to take care of the conversion from one based indexing to zero based indexing. So that basically leads to a lot of errors, but once you write this, then you can just change the indexing format. Now again, we use a queue data structure, and queue will carry the depth and the value that we are at. So what I'll do is, since I'll start at this position, and if let's say if this is the final node, that means I am already a winner. So the number of steps I need to take is 0, and the node I'm at is 1. So I'll treat all of these values as nodes. Now while queue is not empty, the classic breadth first search thing, I take out the top most element or the leftmost element in a queue, or and I'll, let's say, depth and value, the value of this node and the depth I was at, and I just remove that from the queue. Finally, what I would do is I'll check if this value is my final value, that means it's the last value, then I just return whatever it was its depth, right? Because I've reached it for the very first time, and this is the minimum, because we are using a breadth first search. And for this, I want, why this would give the minimum value is, I would like you to go through the game trees, or the how the game changes from state to state. So that is something that you have to look, and you would, if you, there's a proof as well for this. And if you want some hints, you could even search something like a star search. So basically a and asterisk space search. If you do this, you would get a pretty good idea of what I'm trying to do. And if you try to use a very special case of a star search, is actually the breadth first search. Okay, so now since it's not my final value, that means I can still have some moves from that location, right? So what I do is I take I equal to 1 to less than 6, and what I do is I find the next position, the next value that I can go to. So for 4 I can have 5, 6, 7, 8, 9 and 10. So these 5 values I'm taking, and I'm saying if next val, that means this new value that I'm getting is greater than the final value. Let's say if I'm at position 34 and I get a value 6 on the dice, what I do is 1 2 3 4 5 6 is way beyond the board. So if at any point I just go beyond the board, I don't even check anymore, because for 34 if you get 3, you'll be off the board, and same would be the case for 34, I mean 4 5 and 6. So whenever you find this condition, you just break out of the loop, because you cannot, you know for sure that you cannot go any further than that. Now at this position, what I see is, we'll discuss this in a moment. Now the classic BFS thing is, you see that if this next value is not visited, you mark that as visited and you push that into the queue, and you go through this while loop again and again till the queue is not empty. And if for some reason queue got empty and you never reach the end point, that means you can never reach the end, so you cannot win. So in that case you return just minus. Now let's look at this whole point, and this is for this thing. Where is it? This thing, for this comment that I showed you earlier, that is what this 5-6 lines of code is containing. So first of all, given this val, I find out the row and column. Using this convert to RC function, I get the row and I get the column. Since this is returning a pair, I just write pair. Rather than writing pair of int comma int, I just write auto, so that automatically determines the type in a way, and you just get the first and the second number, row and column, and you check if that board row and column is not equal to -1, right? So at this point of time we are going to check, or we are going to use this board that we had as an argument. Till now we did not use that, right? Now what this would do is it will check if this is not -1, that means I am at a position that I am standing on the head of a snake or at the bottom of a ladder. So this is that condition, and if that is the case, my next value would be the value presented on this board. And since we can only do a single jump, or if possible I can only travel a single snake or a single ladder, I have a single if statement. Let's say for some reason if you had a loop, then you could have written a while loop here, but since the question clearly mentions that you do not follow subsequent snake or ladder multiple times in this case, so you do a single if statement. And again, after this, since if you are at a position of a bottom of the ladder or head of the snake, you have to update your next value, and for that next value you would do the checking, right? Because going to that position is not the final position that you ended on. The final position is stored in the board at row comma column. So as I showed you, this was not required at all. What we required was this function, right? But this is just for your reference if you could understand it. And if you see, the code is running very well. And I whenever I submitted this for the very first time, I had some error because I did not read this part. You do not follow the subsequent ladder. So what happened was I used a while loop in this case. So through that while loop I was stuck in an infinite loop, and through that gave me an error in this test case. So I was just trying to do that, it worked or not, and in the end this is working fine. The only mistake I made was to use a while loop here. So keep that in mind while you're writing the code. Read the question properly. That's the only thing that you have to do. So in a nutshell, what this question is demanding you to find the apostrophe hidden style to the location on the grid. First thing. The second thing would be the breadth first search logic, and the third thing would be to know that you could get stuck in an infinite while loop. So the time complexity would be same as what is of the breadth first search. And yep, thanks for watching this video. This was like one of the best questions that you could possibly ask in an interview, let's say. But this is a very interesting problem. Understand this, you would literally enjoy. If I show you, it's accepted as well. It's working, it's good. So yep, thanks for watching, and I'll see you in the next video.